Okay guys, Assalamualaikum warahmatullahi. Bismillahirrahmanirrahim. As I promised before, so we shall discuss the example and the exercise inside your single phase induction motor syllabus or parts. So here are the questions that given in the section. It is given that 4-pole 50 Hz motor, induction motor. So regardless in the induction motor is a single phase or 3-phase, so we have a slip and in term of how we want to calculate the speed, synchronous speed, and the mechanical speed or the motor speed, almost the same. Okay, in term of slip, we have a slip that the induction motor usually presented in terms of percent. So the range or the amount of the slip usually is below 10%. So you just imagine in terms of let's say you have a kite. You draw a kite here, layang. So when you play a kite, you will have a string on the kite and you will pull the kite to the direction of the incoming wind. And so we have incoming wind. So this incoming wind is considered as your magnetic field. And magnetic field. So the higher the wind, so it means that the higher the field will be. And so what happens that when you move to the wind direction, so you will have your kite to be pushed upwards. And to be pushed upwards. So this is your F. And your F means that the higher the magnetic fields or the winds, so the higher your F will be, and the force to push your kites upwards. So this is your kite, so this is the force. So if you are pulling to the direction of the wind, so this is your I. And so F we mentioned before, or we learned before, F is equal to I L times B. And this is all in vector. So B is your magnetic field strength. L is the length of your copper bar inside your motor. And you have your copper bar inside your shaft. This is your shaft. This is your motor, rotor. And so this is the copper bar. The length of the copper bar, the higher the length or the longer the length, so the higher the force will be. So it's the same as your field and your current. So the faster your move means that you are dragging more current to the your kite. So the higher your kite will raise. And so this is your slip. The difference between yourself means that the moving power, the dragging power, which is your magnetic field rotation, and your kite, this is your motor. So this is your slip. And the difference between the driving force, which is your magnetic fields, and your motor. So this is the slip. So the higher the B, so the higher the kite will be. So the longer or the smaller the slip will be. So if you have a more B magnetic field, so your kite will be here, and so it means that your slip will be lower, low speed, slip. If your B is low or your current is low, you move slowly, so your kite will be around here. And so this is your kite. So you have a bigger slip. So your slip will be bigger. So this is the concept of slip. Higher force, you have low slip. Low force, low magnetic fields or low current that flow into your system, so the higher the slip. So the slip will be usually 10% and below. So this is your slip. So hope you understand about the slip concept. So please don't sleep. What I mean is that please pay attention and don't sleep inside the class. Okay, another concept is that regarding the pole. Okay, for your motor to work, you have to have a magnetic field generated inside your magnetic field stator in terms of poles setting. So minimum pole is 2. One set of pole means North Pole and South Pole. And then it comes with another average nilai genap, which is 2, 4, 6, 8, like that. Okay. So let's say we have 4 poles. So assume that we have 4 poles. So these 4 poles represent like your bus stop. If you have a bus, commutating bus. So if we have more poles, so the bus will have more stop pit or place to pick up your passenger. So if you have only 2 poles, so it has only 2 stop pit or place to stop by and pick up. So it means that it will commutate faster. Stop here and then just stop here. But let's say if you have a 4 stop pit or place to pick up the passenger, so you have more stop in place and it consumes more times. That's why you have a formula which is N is equal to 120 times F over divided by P. So the more poles, we have 4 poles here, so the more stop pit, so the slower the synchronous speed will be. So let's say if we have even though in 3 phase, if we have only 2 poles, so the speed will be higher. Even though we have 2 poles, so all the poles will lump together in 2 sides, left and right. We have red, yellow, blue, and on the side we have also red, yellow, blue, 3 phase. So we have only 2 poles, so the bus will have only 2 places to stop and pick up the passenger. So the rotation will be faster. So that's why the synchronous speed, which is Ns or N synchronous, is equal to 120 times F over P. The higher the P you have, so the more stop pit you have, so the lower the speed of synchronous value will be obtained. So let's say you have a higher kind of frequency. Instead of 50 Hz, you have maybe 60 Hz. So the higher the synchronous speed will be. In terms of your application inside your field, maybe you have a conveyor. Let's say you have a conveyor. And usually the conveyor will use a motor. Will attach to the motor. This is your motor. But the conveyor will move in very slow speed. And the speed or the Nm is very low. In terms of maybe a few meter per minute or few RPM. But the motor usually, if we have a higher poles, let's say 4 poles, the speed will be in terms of 1000 RPM. So how we accomplish in terms of reduced speed here? So usually in your factory they have what's called ratio gearbox. You have a high rotational speed here. Before it enters the roller, you have a gearbox. So we have a mechanical gearbox. So the gearbox will have a turn ratio, and the turn ratio will be 1/100, and means that you have 100,000 RPM here, so only 10 RPM on the conveyor side. So you don't have to fabricate in terms of too many poles to achieve a low speed to comply your conveyor requirement. Instead of, you just use gearbox. So you use gearbox here. And so this is the practical or the most common practice in the industry. Okay, we turn back to our question now. 4 poles, 150 Hz motor. Calculate your speed when induction motor has a full load slip of 3.4%. So for question 1, the synchronous speed, calculate the motor speed. So what we have to calculate is first is the synchronous speed, which is 120 times frequency over P. So you will get 120 times your frequency of 50 Hz over 4. So the value will be 1500 rotational per minute or RPM. And so your motor speed will be full speed minus your slip times your synchronous speed. And so you have to minus your slip. So slip in percent. So 1 minus 3.4 over 100 times 1500. So you will get 1449 RPM in terms of your motor speed for question 1. And then question 2. 208 volt, 10 horsepower, 50 Hz induction motor, 5% full load speed, slip. So usually the slip will be mentioned in full load. So what is the synchronous speed of the motor? Same, NS is 120 F divided by P. So you will get also 1500 RPM. Please don't forget to put your units. Okay, this is your synchronous speed. Then what is your motor speed? You calculate the same like above. You shall get 1425 RPM. And 1 minus full load speed minus your slip times NS. This is your amount. Then what is your frequency of your rotor and the rotor frequency. So from the formula given, or the concept is that the slip amount of your motor and the system, you times your frequency of your system, so that is your rotor frequency. So slip is 5%, 5/100 times 50 Hz. So the amount will be 25 Hz. And 25 Hz. So this is the rotational. See, actually you have a stator, you have a rotor here. So how much your rotor turns compared to the original, your magnetic field, and your E here turns. So the difference between your rotor and your magnetic fields, this is the amount of the speed of your rotor, which is 25 Hz. So the amount of your slip times your full frequency of your system. So this is your rotor speed. So the value is 2.5 Hz. Sorry, 2.5 Hz, not 25 here. 2.5 Hz. So the difference between your rotor and your frequency system. Okay, we shall see the next example on the final page, last page of your notes in the next slide.